Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. So I'd like to start off our event today by thanking TIBCO for sponsoring today's event. TIBCO is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, today's event is entitled Connected Intelligence Solutions with AI and ML, and that'll be presented by TIBCO. But before we begin, I'd like to briefly review the format of today's webinar. Today's event will be about an hour long. We have one presenter who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation, and today's event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. And I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speaker, Michael O'Connell, with TIBCO. Michael is the Chief Analytics Officer at TIBCO. He develops analytics solutions across a number of industries, including financial services, energy, life sciences, consumer goods and retail, telco, and media and networks. He's been working on statistical software applications for the past 20 years and has published more than 50 papers and several software packages on statistical methods. Michael did his PhD work in statistics at North Carolina State University and is an adjunct professor in statistics in that department. So Michael, hey, thank you for being with us today. We're looking forward to your presentation. TIBCO,
sure thing.
Oops, excuse me. I went one too far. TIBCO Connected Intelligence Solutions for energy and utility companies provide powerful capabilities. The platform connects data, systems, processes, and people, and it delivers predictive analytics, AI, and data visualization for all aspects of asset management, customer information, distribution, forecasting, production, and supply chain. The TIBCO platform can help you reduce cost and downtime, increase output, and improve customer retention. It lets you embed machine learning into sensors, processes, and equipment for modern grids and smarter oil fields. So Michael, with that, I'm going to turn it over to you. You can begin just as soon as you're ready to go.
Thank you, Bill. And yes, I'm going to speak to you today about TIBCO Connected Intelligence. I will be drawing some examples from IoT and the energy sector. Particularly, though, I'm going to focus on anomaly detection as a use case, which has far-reaching applications. And I'm going to describe the application of TIBCO Connected Intelligence in that context and get into a little bit of the underlying components, Spotfire 10 for visual analytics, TIBCO data science for machine learning and model deployment, and TIBCO streaming for event stream analysis. And I'll show you how to get started as well on some of these tools and solutions. Now, I think it's important for us to stand back a little bit and realize that every data point begins as some sort of real-time event. Now, we accumulate those data into data lakes or databases for population inference, and we build out models that create insights, but the insights are perishable, and we need to take action before they decay. The insights actually decay faster than the data themselves. So a lot of AI successes and analytics success stories have been where you found an insight in the historical data, but you've also been able to apply that to take action on an event stream or on a batch production analysis or whatever it takes to get the insight into production operations to take action, at the right time. And if you think about those right times, we often call them the moments of truth on the business, where you have an opportunity to predict the impending equipment failure, manage inventory, optimize pricing, prevent fraud, deliver proactive customer service, right when you have the customer on your website, or right when you find out that the equipment might have a higher propensity to fail, or right when you want to provide a real-time price. It's that combination of having historical insights from data at rest and applying that to data that is in motion. And the TIBCO Connected Intelligence portfolio allows you to do this. I'll be focused on the Augment Intelligence side of the portfolio today, our data management, data science, and data visualization products. And we have another set of products for API-led microservices integration, messaging, event processing, business process management. And we'll touch a little bit on those as well. We do like to take a portfolio approach where our products are tightly integrated but loosely coupled as to stand alone on their own. We'll be covering these top few areas today: visual analytics, data science, streaming. We offer these products anywhere and everywhere, on-premise, hybrid, and cloud environments. And we also offer our own TIBCO Connected Intelligence Cloud, which has a number of our products up there: integration, live apps such as a BPM product, messaging, Spotfire, Mashup, our API product, with a common set of billing and services, single sign-on capabilities in the TIBCO Connected Intelligence Cloud. Now, putting these products together, you'll see today as we start to bring data in through, or connect to data, I should say, driving calculations often down into the data lake or the database with products like TIBCO Data Science and TIBCO Data Virtualization for providing federated views across a variety of source systems. And then start to understand what's going on in those data with some visual exploration and data discovery with Spotfire, codifying out a model or bringing together some features from raw data to drive a model or machine learning application, and then putting that out into an ecosystem where it can be managed and deployed across event streams. We have a number of products there: business events as a state machine, StreamBase, real-time math on an event stream. Flogo allows you to embed machine learning models in a lightweight edge device. So these are the combinations of the products form these systems of insight that I'll talk to today around the use case of anomaly detection. But let me just show quickly a customer of ours who's in the news, doing some great things with our platform, particularly the data science elements of the platform. It's a customer of ours, Leidos, who uses our data science product in the cloud, AWS, with a variety of their customers on their advanced analytics and data sharing platform. Most notably, we just saw a landing on Mars, and we're working with NASA to analyze the effects of time in space on medical aspects of astronauts. If we start to go out further into deep space and then to Mars, we need to understand those sorts of effects, and we're using TIBCO Data Science to do that. With the CDC, disease outbreak monitoring, with NIH being able to understand outbreaks of epidemics, the opioid epidemic, for example. The work with these government agencies has resulted in understanding little pockets of the opioid epidemic, and also has led to pulling a drug off the market that was contributing to this. Center for Medicare and Medicaid, understanding how to move from fee-for-service to value provided in healthcare standardized across different states and federal agencies. This is a platform that's got wide application and deployed in a number of areas, and using some of the data science pieces that we'll be talking about today. So TIBCO Data Science is a platform that allows you to connect to data, to do feature engineering and modeling at scale by driving calculations down into the data lake or the database, to model, lifecycle manage the model for deployment into operations, either through batch automation or real-time event processing, and then to infuse those predictive model insights into a set of business applications. For example, I mentioned the epidemic monitoring, engineers for yield optimization, quants for trading desk reconciliation. Basically, wherever you have a business application that can be informed by analysis of data at rest, infusing that into the application. So that's where the combination of BI and AI takes hold. But you'll see all of these elements from data connection, feature engineering, modeling, operations deployment, and business applications play an important role. So I'll be focusing today on this use case of anomaly detection. It's a widespread use case. you see it in IoT and engineering applications. Formula One is a great example of that. The season there just finished. We were involved in that. I'll touch on energy sector for production surveillance and drilling optimization, predictive maintenance. In the manufacturing sector, it is used for run-to-run control, fault detection, yield optimization, maverick lock detection. Financial services for trade surveillance, fraud detection, risk and compliance monitoring. In the healthcare sector, patient risk in the hospital, surgical site infection, sepsis, cardiac arrest. And then in customer analytics, when you have folks either on your website or in your store, being able to cross-sell, provide the right offer to the right customer at the right time, that sort of thing. So a far-reaching use case that we have in focus today. So to start off with this use case, one of the great examples of this is in car racing and F1. And we were pretty excited this year to be part of the Mercedes F1 team. The guy there, Lewis Hamilton, just won the driver championship a bit ago, and then bottom left, Mercedes also won the car constructor championship. So they won both of those, and we were heavily involved in the analytics for the operation. We get data from a lot of different places. From a weekend race, we'll typically get almost half a terabyte of data on the tires that are used, the lap, the sector, the car position, the outings, the configuration of the car. And we've done a bunch of work on race strategy. We've built a machine learning model to understand the probability of overtaking the car in front based on things like the latent speed differential, the difference in the tire age and tire type, the position on the track, things like that. We've been involved in applying those models to simulations for the races ahead of time to understand different scenarios for the strategy of the race. And we've been involved in the car setup and R&D as well. Lewis changes gears a lot, typically around up to 3,000 times a race. And so in the setup of the car and the configuration, we use this anomaly detection use case. We were getting, it takes about, I think, 10 milliseconds or so to change a gear. We were getting data at the nanosecond level on several hundred variables and figuring out what are the potential outliers in that several hundred variable dimension space, understanding potential for anomalies in that space, be able to eliminate that by configuring the gearbox in a way that minimizes chance of slippage and that sort of thing. So our work goes all the way from R&D to car setup to race strategy. And you can read about this. Various places have written up how Mercedes uses data and analytics in their F1 campaign. There's a few examples of the recent article here in Forbes is a good one. Computer Weekly, there's a French article, several of those that you can read up on this. Moving on to the energy sector, we didn't learn anomaly detection and event stream analytics on the F1. We've been working with F1 for a couple of years. We've been working with the energy sector and other data-intensive areas for decades. And if you think about the energy sector, the upstream area where you're doing drilling, exploration, production, planning, going into midstream for trading, hedging, downstream for refining, supply, and fuels and marketing. It's a digital business top to bottom, and we've been heavily involved for many years. A couple of examples I'm going to show today for anomaly detection, production surveillance, and drilling optimization. Now, with production surveillance, electric submersible pumps account for a big chunk of production on in the lower 48. And particularly excited to see the last couple of weeks that we're now a net energy producer. We sell more than we import these days. That was only just written into law, I think, 2016, last month or year of the Obama administration. And in the next 3 years since then, we've ramped up production to surpass our imports. And a lot of that is due to the on-ground resource shale plays and being able to produce oil from those effectively. And part of that, these electric submersible pumps play a big role. Most of the high production wells are instrumented, and you get real-time data on electrical parameters, downhole pressures and temperatures, surface pressures, and you're able to monitor these high-producing wells 24/7 with that data to prevent failures, extend the equipment life, enhance production, keep the systems running. these sorts of pumps account for 30–40% of production because they're typically the high-producing assets. People want to keep a handle on them because of their high value. Now, we get data from them, and we are able to bring that into Spotfire to find the wells that may have issues. So clicking on a well here and finding this trace of these spikes here in pressure. Being able to characterize this anomaly as compared to normal function. The screenshot below there shows just random noise. This is a much shorter distance here than up here, where we've got this pressure spiking. And then to characterize the anomaly versus normal function with some rules and models that we're able to then back test on the data history to minimize the false positive rate, but basically set up some alerting conditions as to when you might expect an anomaly to have a higher probability. So this rise in pressure that we're seeing here, one of the features that we engineered was a slope of pressure from one point to another that we can use inside of a model to predict this anomaly versus normal function. So the feature engineering is just as important as the modeling and the rules in the Spotfire analysis, and being able to apply that feature engineering onto the event stream is one of the secret sauce type steps. So as the real-time data are coming through, we're now able to take that feature engineering, cleaning and so on of the data into the event stream and apply the features and thresholds that we developed in Spotfire in our StreamBase event processing platform. And as you start to see this pressure rising up, you can take an action. You can send, if it's a really serious event, you can send a message to the field staff, a cell phone, to shut down the equipment. If it's a less serious event, you can log the notification into the case management database, and you can go look at it, keep your eye on that, and basically clean data and the notifications get written out to an operational data store that you can continue to mine, to investigate, identify bad actors, repeat offenders from the notifications, and do ongoing Spotfire analysis of the insights to close the loop and figure out, is it a real anomaly, is it not a real anomaly? Now you've got some new data, you can go back and retrain the model. So this loop from visual analytics on historical data to streaming analytics on real-time feeds really makes a big difference. We've been able to prevent essentially this type of thing occurring. If you burn out a pump, you're typically offline for some weeks, losing all that oil production. It's also quite expensive to refit the pump. So the ability to extend the equipment life and keep the oil flowing is high value. We're getting in some of our companies hundreds of millions of dollars of savings per year. Just by monitoring these events. And some of the models are quite simple. I showed you the rise in pressure. Typically that's a buildup of gas in the downhole or some kind of blockage in some tubing. So the engineering component to this can be quite easy to resolve to keep the oil flowing. We're also able to spread the organizational best practices digitally. So as we understand those use cases for the anomaly detection, we can bring that into the standard workflows and operational practices and take the knowledge from various tribal knowledge from different folks in the field and bring that into the software. So very, very high value operation here, where we're getting data from these individual pumps. We're analyzing that in the command and control center and then sending notifications back out to the field to manage the pumps. So this is very much a core type of industrial IoT application, production surveillance. Now, the other application I want to show from the energy sector is more of an edge application. So in this case, we are doing the analysis out at the drill rig rather than bringing the data back to the central facility. And the way this works is we're getting data off the drill bit. We're able to characterize the state. So if we look here, we've got depth and time as you're drilling down. You're going through various states here, reaming and rotation, and it's like putting a drill into a concrete wall. You go in a little bit, you come back out, you kind of make your path through, and we are keeping track of the state that you're in, and that allows us to then do calculations on that state to optimize the performance of the drill bit in that particular state. Now, this is a foundational use case for other use cases. You've got to know, are you tripping in, rotating, sliding, things like that. And this allows us to then do things, very high value things like Wellbore trajectory correction. So the right-hand panel here is Spotfire. We're doing a 3D analysis of the blue curve here is the expected or the design for the drilling path. And then the red curve here, red dotted curve here is on the right-hand side is the actual trajectory. And we are in Spotfire able to do the calculations of how to, from any one of these points, how to get you back onto the planned path in an optimal way. So on the left-hand panel here, you can see, in this case, the planned trajectory here. Sorry about that. Is in dotted lines. Here's the actual in the solid line. We can get you back in an optimal way to the planned trajectory. I mean, think of this as, you're going out to a friend's place, you think you know where they live, and you don't put the navigation system on and you get lost, and then you turn the navigation system on and we get you back onto the path in the most efficient way. So we're able to do that in real-time drilling application by applying the corrections that we develop in Spotfire to the real-time streaming path of the drill. And here we're getting data, every second from the drill bit, and we're able to do these calculations and so on in low latency situations. So in this case, as I mentioned, we're out on the edge now. We've got our streaming application for feature engineering and notifications built into the edge drill rig to monitor the equipment right there. But as I mentioned, it's all built on data viz and machine learning that we've done back on the historical data that we're able to apply out on the edge. Now, these applications in the energy sector are high value, but this anomaly detection use case applies ubiquitously across all industries. But as an example of the high value, this article came out, I guess, a year or so ago. Big oil turns to big data to save big money on drilling, and folks talking about saving billions of dollars. They actually called me and asked me, how much is your software? And based on this article, I bit my tongue. I was going to say, how much do people pay for your software? I said, not enough. But I didn't actually say that. I ended up declining to discuss it because it really is such a high value situation, and our software is quite reasonably priced. There's such a big gap there that I just declined to answer the question. But you can see the value generated by these surveillance type use cases for anomaly detection, very high value. As I mentioned, applying these across financial services. I gave you the example of healthcare monitoring in the CDC and NIH. These types of use cases apply everywhere. So today is a bit of an introduction to some sessions that we're going to be doing, in more detail on the road and through our digital series. So I wanted to now jump into just make sure you understand a little bit about what are the products underneath these types of applications where we're doing visual analytics, we're doing data science, and we're doing event processing. So let me get into that a little bit. So Spotfire is the visual piece that I was showing there, looking at some of the streams and identifying some anomalies, understanding patterns across time. And we've recently launched Spotfire 10 just a few weeks ago. And some of the updates here I wanted to catch you up on that are very useful for this type of visual analysis. We've added an AI engine into Spotfire that allows you to, we're behind the scenes, we are finding out patterns in the data. So relationships between a variable that you're interested in, a target variable, and other variables in the data set. And we surface those relationships to you in order of strength in appropriate visual analyses that allow you to quickly create dashboards. We have an NLQ engine also that helps with that. We've made the interface simpler and streamlined for broader usage by citizen analysts. We've got the data prep that you're doing, the feature engineering, the shaping and so on. We keep track of that for you in a data flow on a data canvas that you can then go in and adjust, which is very convenient, as well as having ramifications for compliance, showing all the steps that you've taken from when you first connect to the data all the way through the dashboarding process. And then we've added this real-time insight piece, taking data from real-time feeds and visualizing that in Spotfire side by side with historical data analysis. And this becomes very interesting when you're talking about use cases like anomaly detection, where you can actually see the real-time feed and see where things are going out of spec visually on the real-time stream. So just touching on these, double-clicking down a little bit, this AI engine, when you click on the variable, we, behind the scenes, on a separate thread, we are figuring out relationships of every variable to every other variable. So when you click here, we then suggest to you, in order of strength, the relationships of the variable you've chosen to other variables in the data set. And literally in a few clicks from these suggestions, you can build out an analysis that shows you the relationships to the variable that you've chosen with all the other variables in the data set or in connected data set that you have in your analysis. So this one is a analysis of I clicked on price here. These are Airbnb properties in New York City. I can see how price varies as a function of location, number of rooms, room type, that sort of thing. A few clicks and I've got a brush-linked dashboard there. And this broadens out the user scenario for Spotfire, which is very strong analytically. We've now made that analytic strength and put that in the hands of a much broader user community who may not understand all the menu systems and so on, but the engine is now suggesting the analysis to the end user who can be an entry-level user. The NLQ piece we've added, so anywhere in analysis now you can click on the magnifying glass, the search area, type a question to Spotfire. We parse out your question, we look for data that match the question, and again we show the insights in order of strength and allow you to very quickly create a dashboard based on having a conversation with Spotfire, and that works in combination with the AI engine. The real-time data streams, which is a very powerful component, especially for this anomaly detection use case that I'm talking about. We can connect to any real-time data stream. We actually consolidate that on the back end with a Spotfire server component, Spotfire data streams, bring in data from Kafka or MQTT or whatever you have, a JMS feed. We do data engineering, feature engineering on the data stream, clean up the data. All the Spotfire graphs are now respond to the real-time events. So they, the graphs don't get repainted. The points get slid along to the left, and a new point gets added to the right if it's a time series plot, or the bars on the bar chart move around, or whatever else. So it's true native real-time viz combined with static viz. Now you can do brush link marking like any other Spotfire marking between the real-time viz and the historical viz. It's simple to set up. The connector is to the live data is just the same as any other Spotfire connector, and you can go back and forth between the real-time viz and the historical viz. You can also do operations on the stream, so you can right-click on a moving line chart, for example. There's an option to forecast that on the live viz for that sort of thing. So very powerful analytics on the real-time event stream. And then, of course, not to forget about the leadership we have in Spotfire for just general brush link analytic applications for data discovery. We are not a reporting tool like some of the other vendors in our category. We really are a data discovery tool. When you create a visualization in Spotfire, you create a details visualization. You can connect to any other data source, and Spotfire will manage that connection for you. You can connect data source 1 to 2, 2 to 3, 4 to 5, whatever you want. It just goes on, and Spotfire manages all those connections for you. This allows you to drill up, drill down, drill sideways. Very convenient for data discovery across multivariate data domains. And then the data mashup and data wrangling. I mentioned the point and click that you have available for grouping and working on the histogram, the frequency histogram of the data column with the spot and fix approach that we have to finding distributional outliers, anomalies, and fixing those, point and click. There's also a scripting environment inside of Spotfire. You can use the Excel style scripting or a native R to generate data on the fly. Very powerful for adding calculated columns or features to axes of the graph that get refreshed on marking and filtering. You can bring in a third-party or outside functionality, Python, SAS, MATLAB, Statistica in a point-and-click data function world as well. And we keep track of all that you are doing. We automatically create a data lineage. You don't touch this yourself except to edit. This is set up for you from the point-and-click and scripting operations that you do. but now you can jump in here and you can edit these, you can add rows or add transformations, all the way back, and that'll percolate down through the calculations. So we really take data mashup and data wrangling very seriously in Spotfire. We've been at this for many years, and it's very thorough for setting up quickly data for visual analysis. And then geoanalytics, lots of stuff here on the community site for doing things like contour analysis, points in polygons, real-time viz across mapping, coordinate system overlays, lots of data functions for combining Spotfire data with web mapping services, tile mapping services, Esri projections, and so on. And then the predictive analytics and machine learning, we have some of this inside of Spotfire to get you started, point and click for regression, classification, things like that. But then connection into TIBCO data science, which I'm about to talk about, is very strong. This combination of visual analytics and data science, we're seeing more and more applications for that. And inside Spotfire, you can run your R analysis, your call out to TIBCO data science, which you'll see in a minute, and calls out to Python. So this allows you to build these sophisticated analytic applications very quickly in a matter of clicks, a matter of hours rather than days, and really explore and find the insights in the data at rest and apply that to upcoming data in motion. So briefly then, the differentiated aspects of Spotfire compared to the rest of the BI and analytics tools out there, the ability to create these brush-linked analytic apps very quickly, the data mashup and data wrangling with reusability, editability, the AI-powered insights with NLQ, real-time data streams, one-click web deployment, and then the geo and predictive and machine learning, some built in and some connectivity to our data science products. And then we've been at this for a number of years. The product's very mature. Its scalability on the server side is unmatched. Simple governance with high security, configurability, APIs, that sort of thing. Now, TIBCO Data Science is the other featured product today, one of the other featured products. This allows you to set up, connect various people with various data sources, create projects, data science projects across the business. We don't move any data anywhere. We are a layer of orchestration that allows you to transform and model across the data sources without moving data, to do in database and in data lake, data prep, analytics, machine learning. There's a Python notebook interface that you can drag onto the visual canvas that goes nicely with the visual components. We're very strong against Spark, but we also apply these operations into real-time, into databases like Teradata, Oracle, and so on. And the web visual and notebook combination is particularly powerful. Rapid deployment in the cloud and connectivity into a variety of those sort of data sources. The combination of TIBCO Data Science with TIBCO Spotfire is particularly powerful. You can drive calculations down into the data lake or the database. In TIBCO Data Science, you can also do the same thing in Spotfire and never move data anywhere and have the best of both worlds. And then pushing models out into operations. This is huge. So however you've developed your insight through visual analytics or through machine learning, being able to push a real-time engine out for scoring a new event stream, being able to schedule batch runs of workflows, Python notebooks, SQL files, Spotfire files, connect to streaming data to apply models on the event stream. And this is a huge part of the value that is generated with the use cases that I mentioned earlier. Now, TIBCO Data Science is recognized by Amazon as a machine learning competency partner. In fact, we're the only company who's recognized in two categories for data services, which is essentially feature engineering and so on, and platform solutions, which is the full end-to-end lifecycle management of the process, from the team to the connecting the data source to building the workflow to deploying out the model to manage the model on the event stream, that full life cycle. And we've just gotten back from reInvent. We submitted this anomaly detection algorithm as a Python notebook as part of the AWS marketplace for machine learning, and you can bring that into your environment, your notebook environment, including obviously our world of TIBCO Data Science and also the Amazon SageMaker product. So how do you then apply that insight? You saw the drilling, you saw the production surveillance examples, you saw the Mercedes example. We have connectors in our StreamBase product for a variety of event streams. I think I mentioned MQTT, JMS feeds, Kafka feeds, and inside of the live data cache, we're able to apply those transformations on a real-time data stream in Spotfire 10. So this combination of Spotfire 10 with StreamBase is pretty powerful. You can get going out of the box with that in Spotfire, but you can also go deeper in that whole event processing area with StreamBase. And then Flogo is our product that allows you to take a machine learning model and deploy it on an edge device. Think of an exit sign that's disconnected, or think of a piece of equipment that is managing a process that is disconnected, spends a lot of its time operating with the piece of equipment, in a local kind of manner. We're able to stick a machine learning model out into Flogo for edge ML type analytics. So a number of options here depending on how much footprint you have to work with. TIBCO StreamBase allows you to do calculations on sliding windows on the event stream, inject models into that, do feature engineering, and then put in business logic for notifications based on exceedance of a threshold or combination of a rule with a model score. And we have this TIBCO Artifact Management Server where we publish our models from TIBCO Data Science into AMS, then picked up by StreamBase or Flogo. We can publish from our desktop data science environment as well as our distributed compute environment, and that allows you to build applications combining data science models with business processes or streaming type data sources. So this combination of data science and streaming is particularly powerful. So how do you get started on this sort of thing? If you go to community.tibco.com, you can jump into the various products that I mentioned today: TIBCO Data Science, TIBCO Spotfire, TIBCO StreamBase. You can jump into our exchange. The exchange here has a number of templates and accelerators, starter applications for you to get going with. So yeah, all of the above. If in the Spotfire area, you can go download a number of those artifacts for data science, for geoanalytics, for data viz, for big data analysis, combining the products. There's a variety of components that you can download here. And then we have a partner network, exchange.ai, that has hundreds of Spotfire templates available for download. This is a marketplace, so our partners typically sell some of these. There's a bunch of them are for free. Everything on the TIBCO community side is for free. Some of our partners will sell some of the templates for specialized applications in energy sector or manufacturing or finance, those sort of data-intensive industries that our partners help us with. So some of the things we saw today, we saw some drilling analysis. We have a drilling accelerator that allows you to assemble data, look at the data in Spotfire, train up a model on the event stream, and then case manage the anomalies that have been surfaced. That drilling accelerator is widely used in Houston. More generally, a risk management accelerator for taking an anomaly detection model, building it on a historical data source, applying that to an event stream, and then case managing the anomalies that are produced from application of the model to the event stream. This is called our risk management accelerator, and this is used very widely across a variety of anomaly detection use cases. I mentioned earlier in the finance surveillance, trade surveillance, or even just equipment, IT equipment surveillance, fraud, all the use cases I said I provided earlier: customer analytics, churn, cross-sell, that sort of thing. So that's it for today. That's an introductory session on TIBCO Connected Intelligence with applications to anomaly detection from data science perspective, combining TIBCO Data Science with TIBCO Spotfire for Viz and TIBCO StreamBase for event processing. I wanted to give an introduction to this. We'll be providing materials and drill down versions of this seminar, both live and digitally, for a variety of industry sectors. But at this point, I'm going to turn it back to Bill and open up for questions. These links here are particularly important, community.tibco.com, the exchange for downloading components, and getting started with Spotfire trial on the new Spotfire 10 product. Bill?
Well, Michael, thank you for that excellent presentation. And we'll get started with today's Q&A session. And I want to thank the audience for their participation. We had a lot of questions that have come in, and we'll do our best to get through all of them in the time remaining. And so during this Q&A session, I'll leave up this screen with contact information for Michael if you'd like to contact him following today's event. So let's get started. Michael, you gave a bunch of interesting examples about anomaly detection for production surveillance in energy. Are there other applications for that approach in the energy sector?
Absolutely, Bill. And I mentioned a few of those. We covered the drilling as well as the production surveillance today as examples. But, there's real-time event streams everywhere. Today I showed examples that featured sensor data on equipment. The industrial IoT is a big application area for this. But, we get tons of other data from related industries. I think I mentioned manufacturing briefly, where we're getting data from equipment to do run-to-run process control, fault detection, yield optimization. I wanted to point out that the data, can be high throughput, or low latency, or it can also be slower moving. That energy data I showed from the submersible pumps, data are arriving every few hours, but you've got several thousand pieces of equipment, so the data stream during the day is pretty constant, but any individual sensor reading is typically a few hours apart. In financial services and telco networks, we get data at a lower latency, higher throughput every minute, or sometimes even every second or sub-second. And the customer analytics applications I spoke about, churn and cross-sell, are often somewhere in between those. And there's, most times people want to get a refresh on their analysis quickly, in a visual environment as well as a event processing notification type environment. And there's great value in linking, time series data with contextual data for finding insights in data at rest, and linking those to live data, or sometimes just replaying the event stream is also incredibly informative. So I guess, in general, Bill, the ability to rapidly respond to this torrent of events that we experience every day with both real-time and batch updates of our analytics to find, spot the fire, find the anomaly, find the outlier, has very high value, and we're seeing more and more of this, not just in data-intensive industries like financial services and the energy sector, but more and more across the board. Everybody wants to refresh their data. We just seem to be going faster and faster in all kinds of areas, and so we're responding in our software to meet that need.
Well, that makes perfect sense. Thanks, Michael, for that response. And, in this new exploding age of IoT and streaming data, one of the things that the audience observed was your ability to get real-time visual analytics working on streaming data. Is there a new Spotfire server component or data connector, or how do you make that happen in Spotfire?
Yes. I didn't get into the architecture today, but Spotfire has a server set of capabilities as well as a client set. So briefly, on the client side, we have web interfaces, we have Windows, we have Mac interfaces for working, building applications and viewing applications. And then on the server, we have the Spotfire server that manages different people accessing to the data in a governed way. Doing advanced data services, doing automation for batch analysis, doing stat services on the server, and applying all of those calculations out to a friendly web environment for consumers and broadcasting results and crowdsourcing. We've added a component to the server called Spotfire Data Streams that allows you to connect to a set of real-time data sources, be it Kafka, MQTT, in JMS feeds, and whatever. It's a visual interface that allows you to just literally connect to those sources and apply, push out an output, and that lands in a data mart that is refreshed, and Spotfire connects to that data mart. Very simple to create the connection, just like any other Spotfire connection, except this connection is live. And this connection allows you not only to do a where clause, but to do a when clause. And to do that, seamlessly in point-and-click environment inside of Spotfire, you can do things point-and-click to, adjust the time window that you want to bring in, or adjust the data that you want to bring in, the calculations that you want to do, the forecasting I mentioned on the time series. So from the Spotfire user experience, there's really not any difference to anything else that they're being connecting to. On the server side, there's this additional component, Spotfire data streams, that allows you to connect to those data sources rather than the static data sources, which is handled, through the Spotfire server as it stands today. So yes, Bill, there is that extra server-side component, but very simple to set up and very simple to add that into your Spotfire authoring experience and your Spotfire viewing experience.
Well, Michael, thank you for that clarification. You in your presentation, you talked about TIBCO being an AWS partner, and I think that this audience question is more by way of confirmation. But the question from the audience is it possible to perform distributed machine learning algorithms on time series data with TIBCO?
Yes, absolutely. We just got back from reInvent a couple of weeks ago, and our featured presentation there was to run this anomaly detection use case that I talked about today as a Python notebook with calls into the TensorFlow libraries for doing deep learning. This autoencoder method that we have available for download on our community site allows you to take in a set of inputs and to characterize those inputs with a reduced dimensional space, produce outputs for all the inputs, and the outputs that least match the inputs are the anomalies. So it's a high-powered way of doing anomaly detection. We wrote it up through a Python notebook. As I mentioned, TIBCO Data Science has both a visual environment as well as a notebook interface, and the notebook you can drag onto the visual environment. It'll interrogate and integrate with the visual components, so all the stuff you might have done to visually prepare the data is available to the Python code and the developer there. And we were able to push that out and run that distributed on AWS via connectivity into the AWS SageMaker product. And you can just send parameters to SageMaker, the size of the cluster you want to spin up, the TensorFlow graph that you want to use for the neural net. These are just parameters that you pass into SageMaker from TIBCO Data Science and run that distributed compute parallelized across the cluster. So we demonstrated some pretty big data at reInvent where we were getting compute times down from hours into seconds and minutes using the distributed compute and also using the GPU. So yeah, this, the question is probably coming from someone in the sensor world, IoT world, where those data volumes get voluminous and they're, flowing on a rapid sort of time scale. And so, yeah, we have some pretty serious and significant methods, for managing that sort of data. And it's important to note as well that, the time granularity is an important component. So, we do some time series pre-processing to figure out the in-stream correlation, like parallelogram analysis, to figure out the lags that we need to include in the model. And that's an important component to getting an efficient compute cycle on that torrent of streaming data and big data. So that's a great question. Whoever asked that, feel free to drop me a note, and there might be some things I can point you to.
Oh, terrific. Okay, Michael, thank you very much for that answer. Similarly, this marriage of visual analytics with data science these days is very powerful for just examining data and looking for relationships. And the audience is wondering, does the standardization of format and pre-processing of that data occur automatically? What are the requirements for making sure that data is clean before you start to drill up and down and look for insight?
Yeah, great question. We're seeing this real blurring of the line between data science and visual analytics these days. In Spotfire, we've always had some level of predictive analytics, machine learning available, but we're now providing this AI engine that I mentioned out of the box in Spotfire 10, where we start figuring out insights in your data as you're exploring it, and we present those to you as a series of suggestions. Now, the way that AI engine works we cycle through the data that you're connected to, and we set, in turn, each of the columns as the Y variable, and then we look at relationships with all the other variables as the X variables. And to do that, we do some data prep to do things like binning of some of the columns, depending on the frequency of data available in different categories. Sometimes, data is very messy, as you might imagine. And so when you've got high cardinality of a categorical variable, how do you best deal with that? Sometimes you want to collapse that into bins. Sometimes you might want to bin, some of even the continuous data. So we have a series of data prep and feature engineering that goes on to establish the correlations between the target variable and the other variables. That all happens behind the scenes, and you get presented the relationships, to add to your dashboard. Now, you add the raw data. We are doing that feature engineering and computations to identify the relationships, but the suggestions we make are on the raw data. You then build out your analysis on your raw data, but knowing behind the scenes that we've managed that in an efficient way through the data cleaning and feature engineering pieces. So what we're essentially doing here in the Spotfire world is providing the data scientist type operations that would usually happen manually. We're providing those to the business analyst in a more automated manner. Now, on the data science side of the house, we provide pluggable components for doing feature engineering and modeling, and those are also automated. So we have this notion of AutoML, where you can point our data science product at your data. We will cycle through a number of featureization methods. We will cycle through the fitting of a number of models and changing the hyperparameters in a structured way. And then we will give you some recommended machine learning models and feature engineering that is also pluggable. So now you can mix and match our automated suggestions with your own parameterizations in that data canvas that combines both the drag and drop as well as the notebook environments. So both of our products, on the visual analytics side and the data science side, have this internal engine in them that is suggestive to the end user to make their life easier, but they're also, overridable, pluggable, parameterizable, editable, and so on by the end user. So we're seeing this real blurring of the line between visual analytics and data science, and we're trying to make our software suit the different personas. So on the BI side, the analyst side of the house, we're trying to provide these easy-to-use suggestions. But on the data science side, we're doing that, but in a more of a data science context, so that the end user can actually see the transformations, see the models that we're suggesting, and take over full control themselves. So for the different personas, we're trying to provide the right level of suggestion and AI componentry that make their lives easier while giving transparency into what's going on under the hood. Sorry for the long answer, but that's a kind of a combination there where all the stuff we're doing on the visual analytics side and all the stuff we do on the data science side, that's what I tried to cover there in brief.
Yeah, that combination of those two areas is really powerful these days. And while we're on the topic of visual analytics, an audience member is wondering about the services that TIBCO provides. They're asking specifically, do you help your clients build those dashboards and applications for visual analytics, or is that something that your clients generally do for themselves?
No, absolutely. We have a whole services component, you can call it the Center of Analytics Excellence, helping our customers get started with either with the server deployment or with the authoring, full enchilada, whatever the customer wants. But to deploy best practices and a Center of Excellence, is a very worthwhile thing. Lots of ROI in that, and we're there to help with that. Also, our community site and the partner community exchange are a wealth of information for best practices, configurations, templates, ways to get started. So it's all of the above. I think people want to be able to get help when they need it, but they also want to have a structured environment where they're supported on a daily basis.
Well, Michael, thanks for that clarification. In your presentation, you went by so many features in TIBCO, and many of them seem to be new or expanded. Take, for example, GeoAnalytics. A lot of that seemed to be new. How do we keep up with how TIBCO is evolving? And let's talk about GeoAnalytics.
Sure. Well, just go to Google and say, what's new in Spotfire, or what's new in TIBCO Data Science, or what's new in Spotfire Geoanalytics would be a way to start. But, the geoanalytics component of the community.tibco.com is very comprehensive. So you'll see templates for, calculations on the layers of the geo, route optimizations, trade area analysis. You'll see, things like calculating points in a certain polygon from one layer to the other. Some of the foundational calculations that you want to do, your layer data might be lat long in Spotfire, might be TMS or WMS data coming in from a web service. It might be an ARC GIS shapefile or a service. And being able to do calculations within and between those layers is something that we provide both through the point-and-click tools, but also being able to run an R script or a Python script across the layers is something that's particularly powerful. And you'll see a number of examples if you go to community.tibco.com and go to the Spotfire area and then into the geoanalytics area as well. And, just Googling this without, at the high-level Google line, just Google TIBCO Spotfire Geoanalytics and you'll find some great stuff.
Oh, terrific. Oh, thanks for that clarification. The visual analytics is such a strong area, and clearly that's something that TIBCO intends to really exploit. What's next for TIBCO in visual analytics?
Yeah, so this Spotfire 10, I've been with the company about 10 years, and this is the biggest release we've ever had, adding features for this augmented analytic experience with the AI engine, NLQ, adding the real-time data stream, which is so applicable for the use cases I spoke about today, anomaly detection, adding this authoring from the data canvas and automatic generation of the data lineage. These are all big features. And yeah, so, there's going to be more of the same going forward. In fact, the AI engine, we've started some work on, data science squared. So data science on the usage of the data science that we're using in the AI suggestion engine to improve the recommendations, to allowing people to control the recommendations, give them a thumbs up, a thumb down, and then, factoring that into the next set of recommendations. So that's a very active area. The data prep stuff and the data canvas is pretty full-featured now. We've been at that for a while, so that's mature and highly functional. You'll see more coming along with the combination of real-time data streams with analysis of historical data, and just more improvements on making the rich depth of Spotfire to surface that to more users in various suggestion, query type interfaces.
Yeah, you really sparked our imagination in this this intersection of visual analytics and data science and streaming data, IoT, and we talked about IoT and engineering applications. What other applications can you suggest for folks that might be listening in? Where can we apply what we've seen today in areas outside of engineering?
Yeah, broadly speaking, we like to cover the engineering and IoT area like we focused on today. And then the other side of the coin is typically customer analytics. So being able to have a good journey for engaging with the customer. I mentioned churn and cross-sell as obvious use cases, but just refreshing, web analytics, social analytics, data coming from, a variety of sources. We have a full life cycle analytic applications that we apply to our own internal data at TIBCO, and that area is, blowing up as well. And then I think other specialty areas in, outside of IoT and engineering and customer analytics, I mentioned briefly today, financial services, risk and compliance modeling, fraud detection. I mentioned some healthcare and pharmaceutical applications, around clinical trial management, biomarker prediction of endpoints, patient risk analysis. So yeah, healthcare and pharmaceutical is also blowing up. And then I also touched on telco, media, and networks, where we're managing network operations, both the telco customer side of the house, but also the network operations side. So the list is never ending, and the applications I showed today around anomaly detection for analyzing historical data and applying that to new data I chose that one for the small time we had today because I think it's expressive of a broader collection of use cases that occur not just in engineering, manufacturing, energy sector, and so on, but also FSI and healthcare, customer analytics, telco, and so on. So yeah, I think you'll see, that use case. If you dig into that, it'll be applicable to your world in some way, shape, or form.
Well, Michael, hey, thank you for some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Michael and the TIBCO team so they can follow up with you after today's webinar. I have just a few quick announcements. If you'd please mark your calendars for December 12th, that's tomorrow, and our next DSC webinar, which is Data Prep for Data Ops, How to Select and Deploy. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Also, our past webinars are available on demand at Data Science Central. And if you haven't had the opportunity to take a look at them, I encourage you to check them out. They provide some very useful insight into a wide variety of topics of interest to our data science community. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks to TIBCO for their sponsorship, and particularly our speaker today, Michael O'Connell, for his insight into today's topic. This is Bill Vorhies. I'm very pleased to have been your host for today's event. Look forward to seeing you all again tomorrow, December 12th. Have a great day.